So today in this lecture we are going to discuss about this IC 555 timer and its pin configuration with a basic explanation. So the very first thing we have to think about why IC 555 timer. Here IC stands for integrated circuit, in which so many number of circuit elements and components are enabled together or clubbed together in a single place called chip, which are basically used to operate various different functions. Now as we can see here timer. So timer means some kind of things which is very much or fully associated with the time only. So it can be to count something we need the estimated time, or to make some pause for doing some kind of operations called delay. So the amount of time to get delay are the basics of timer and its applications. Now here our main topic is about IC 555 timer, which is a 8-pin DIP. DIP basically dual line package in the and it is the types of configuration of IC. Here the IC 555 timer was first invented by Hans Kammerjeen in the year 1971, and first it was marketed in the year 1972 by the company name is Signetics, SIGNETICS. Now, coming to depending upon the manufacturer, the standard IC 555 package are built with 25 numbers of transistors, 2 diodes, and 15 numbers of resistors in a single chip. That is DIP, dual inline pin package. Now, why this 555 name comes? Why not any other 666 or 888? As because the circuit consists of 3 numbers of 5 kilo ohm resistors in series. So in this video what actually we're going to discuss, we are going to discuss means we'll cover here the theory part about IC 555, just what I told you, this pin diagram and this internal circuit diagram, the application and multivibrators. So IC 555 timer is widely used for variety of timer delay, timing delay, pause generations, oscillator applications, and for the it is basically used as a square wave generator. So as I told you earlier, the pin diagram. So IC 555 is 8 pin base IC, and here this you can see this is called notch. So just to make sure that the right directions you are taking, so the left side of the notch will be started from the number 1. So that means this is the closest part, or you can say the closest part of the notch of an IC will be the starting pin number. So here in the left side we are taking pin number 1, 2, 3, 4, and here 5, 6, 7, 8. Now in this IC 555 timer, it has 8 pin. So the very first pin number 1 is ground pin. Pin number 2 is trigger. Pin number 3 is output. Pin number 4 is reset. Pin number 5 is control voltage. And pin number 6 is threshold voltage. Pin number 7 is discharge pin. And the pin 8, this is your VCC pin. Right. So this pin number 5, if I tell you about this control voltage, basically this is the control voltage. From this voltage we can control the discharge pin 7 and the threshold voltage pin 6. Reset pin number 4. Pin number 4 means reset pin. This is basically used to reset the total output of this 555 timer. And from the pin number 3 we can get the output. And pin number 2, this is the external trigger, means excitation you are supposed going to provide any kind of input from the external sources. And pin number 1 is ground, and pin number 8 is VCC, means supply voltage, right? Now coming to this internal circuit diagram, if I tell about this internal circuit diagram, this total internal, this is our internal circuit diagram structure. You can see very different kind of circuit diagram, but basically these are the components. So in this total internal circuit diagram, it comprises of 4 different circuits. The first one is voltage divider circuit, and number 2 is 2 number of comparators. Here C1 and C2, these are the 2 comparators. Again I am going to discuss it. Then SR flip-flop. So I'm going to tell about this is our SR flip-flop block. and then discharge circuit. From this pin number 7, actually this is your discharge pin, our discharge pin. So this is a transistor here we have associated, so discharge circuit. Now coming to this, now we are going to discuss about this internal circuit diagram. So see here, I told you earlier in this we have a voltage divider circuit. So in this voltage divider circuit, and as the name is a 555 timer, I told you earlier that three 5 kilo ohm resistors are connected in series. So from this VCC, suppose this is our VCC with this pin number 8, and three 5 kilo ohm resistors R1, R2 and R3, these are connected in series. So this is our voltage divider circuit. Here from this two comparator, basically comparator is nothing but a kind of op amp. So here these are threshold voltage from this pin number 6, these are pin number 6, these are pin number 5, from this pin number 5 these are control voltage, these are pin number 2, this is a trigger, this pin number 1 is ground, and these R2, C1 and C2 are the basically op amp, means a comparator, two comparators are there. And here we have taken one SR flip-flop. So from this will be our pin number 4, that is a reset pin, and pin number 3, this is the output. Sometimes we have to take the power amplifier here. If I talk about, suppose if I take a power amplifier here to make it the output amplified version, power amplifier, okay, just like if you think this is the connected, so here we can get this output. So this will be our final output. Now talking about this, so this is pin number 7. So already I discussed in this internal circuit diagram, total pin number 8 is VCC, pin number 6 is the threshold voltage, and then pin number 5 is control voltage, pin number 2 is the trigger, pin number 3 is the output, pin number 7 is the discharge pin, and pin number 1 is ground pin, pin number 1 is our reset pin. So first I told you here also the voltage divider circuit, so we are going to discuss about this voltage divider circuit. Suppose according to the voltage divider in this circuit, previous circuit, if we see here, we have three numbers of 5 kilo ohm resistors that are connected in series. So these are our 5 kilo ohm 3 resistors that are connected in series. Now to find out the voltage across the resistors as per the voltage divider circuit, suppose here as an example I have taken three different resistors RA, RB, RC, and these are the 3 points I have taken, point A, point B and point C. Now suppose if I provide VCC is a plus 9 volt, the supply voltage. If I want to find the voltage across this point B, what we need to do? The formula is simply the number of resistors left. So at point B here, suppose if I going to find out the voltage source, suppose this is your VB, this is VC, and this is suppose VA. So the VB and B and VC are the respective voltage at the point A, B and C. So the formula is at point B the voltage will be the number of resistors left, means 1 and 2, RB and RC. So the number of resistors left by the sum of all the resistors into VCC or the source voltage. So here number of resistors RB and RC. These are the two resistors left from this point B. So it will be RB plus RC, the number of resistors left, sum of the number of resistors RB plus RC by total number of sum of all the resistors RA plus RB plus RC into VCC. So here this will be your RB plus RC. So RB plus RC by RC, but here RB plus RC by RA plus RB plus RC into VCC. But if I ask you about this point C, then see the left resistor is only 1. So the voltage at this point, means at point C, will be RC by RA plus RB plus RC, means the number of resistors left by the total number of resistors into VCC. So just like the IC 555 timers, we have taken three equal resistors RA, RB, RC equals to suppose 5 kilo ohm. Already we have taken in this previous 5 kilo ohm are each of 5 kilo ohm resistors. So VA will be this one, RA plus RB plus RC by RA plus RB plus RC into VCC. So into VCC equal to VCC. Now at point B, the voltage will be, suppose at point B, suppose this is at point, this point pin number 5. What will be the number of resistors are 1 and 2. So R2 by R2 plus R3 by R1 plus R2 plus R3, that means 5 plus 5 by 5 plus 5 plus 5. So here I have written here RB plus RC by RA plus RB plus RC into VCC. That means here as we have taken RA equals to RB equals to RC. So anything I can take replace. So here we have taken all are RB replaced by RB. So RB plus RB by RB plus RB plus RB plus into VCC. That 2 by 3 VCC. Or simply at the point C voltage will be VC. Now suppose at this point if I talk about this point, so the number of resistors are left only 1. So this R3 by R1 plus R2 plus R3 into VCC. Here I have taken the same thing, RC by RA plus RB plus RC into VCC. Now equals to I have replaced as, because RA equals to RB equals to RC. So directly what we have done, RC by RC plus RC into VCC equals to 1 by 3 into VCC. Or if we put the value of individual resistor, that is also 5 by 5 plus 5 plus 5 into VCC equals to 5 by 15, that is also 1 by 3 VCC. So finally we got VA equals to VCC, VB equals to 2 by 3 VCC and VC equals to 1 by 3 VCC. Now again coming to this internal circuit. So the first one we got it, voltage divisor circuit. And the second one now, comparators. Here are two comparators. What are actually comparators? Comparators basically they compares with each other and then provides the output. Now suppose this is a comparator, we have taken one op amp. We know this plus means inverting non-inverting terminal and minus means inverting terminal. Suppose this V1 and V2, these are my two terminals. V1 is non-inverting terminal and V2 is inverting terminal, right here. And from V0 this is the output section. So the output of comparator is equals to A into Vd. What is A? A is the gain and Vd is the differential voltage. So differential voltage means this is the Vd, V1 minus V2, V1 minus V2. Here I have written NIVI, sorry, NIVT. NIVT means non-inverting terminal voltage, non-inverting voltage terminal, and IV means inverting voltage terminal. Non-inverting terminal voltage and inverting terminal voltage. So here when V1 will be greater than V2, that means this is my positive, so I will be getting the output will be high. If this is V1 equals to suppose 5 volt and V2 equals to 3 volts, obviously 5 minus 3 equals to 2, I will get the positive, that means high. This is the output, V0 equal to 1 we can say. And now suppose if V1 is less than V2, then the output voltage will be low. So that means V1 is suppose 3 volt and V2 is suppose 5 volts, so 3 minus 5 equals to minus 2. That means we are getting lower voltage here, so it will be 0. Sorry, it will be 0 in terms of the state, lower state, higher state. Now again we go back to the circuit. We have a flip-flop, and flip-flop is nothing but this is a memory element we can say. So SR flip-flop we have taken here. So now just come here, SR flip-flop. So SR flip-flop, obviously any kind of flip-flop here we have taken. We have a flip-flop that is suppose our input section. So 2 input, again we are getting 2 output, right? So the truth table of SR flip-flop, if we take only the 2 states, 2 input, we have taken 0 and 1. So for this 0 and 1 we can make 4 different combinations: 0 0, 0 1, 1 0, 1 1. So these are the possible combination we can make: 0 0, 0 1, 1 0, 1 1. Now suppose in both the cases S and R will be 0 0. There is no kind of change, no changes. That means 0 and 0, either it will be it will goes to the previous state before applying any kind of input, whatever the state earlier it was held, so that same input it will remain. Now coming to the next 0 1. So for these things we will get, if we apply 0 here, if we apply 1 here, what you will get? 0. So obviously Q1 Q bar. So this is the complement to each other. That means these are inverting. In digital circuit, we say these are complement to each other or inverting. Whatever the result, suppose you are providing high here, you will get low here. If you provide low here, you will get high here. So just opposite. So that means 0, 0 bar, it will 1. Now again 1, 0. In S, if you provide 1, in R, if you provide 0, you will get 1, 0. Opposite. So if you get 1 here, Q, it will be 0. And for the cases, if we provide for both S and R, 1 and 1, what will happen? There is a kind of impractical thing will happen. Suppose if I get 1, again, 1 should be, it is not possible to get the same result in both cases, Q and QR. And that is why it is known as undefined or forbidden cases. So basically we'll deal with this 3, or sometimes we will deal with this 2 only. Right? So one more thing is there. So from their output, pin number 3. So pin number 4 is reset pin. And now here, one is transistor is there. So we know there is a difference between diode and transistor. Diode is basically, it acts like a rectifier, basically used to convert from AC to DC. But in transistor, it acts like a switch. Here we can see this is a base, this is a collector, this is emitter. Right. So this, from this, what we can do in this transistor, whenever we apply high voltage to the base of a transistor, these are base of a transistor, when we apply high voltage, it goes to the saturation region. And the saturation region means it actually, whenever if we connect with a capacitor, the pin number 7 will provide a path to discharge. In the saturation region, it will goes to discharge. But when in low voltage, if we apply to the base of a transistor, it operates in the cutoff region. That means it will be in the off the conditions. Therefore we can say the transistor acts as a switch here. When switch on, the discharge path, but the discharge directly will not go here. That means if we connect here through this path some capacitor, then only discharge will be happening. Now suppose again, if we come back to the switch off, that means cut off the discharge path. So see, and the final thing I told you here, this is discharge circuit. So this thing done, this thing done. Now we are going to this discharge circuit. Here see, suppose we have a 9 volt supply. This is my VCC, right? We have a resistors connected and this is a capacitor. I told you how this transistor actually acts in this discharge circuit. If S is nothing but a switch, and that switch may be replaced by a transistor. I told you that transistor can be act as a switch. So whenever if the switch is open, directly this kind of things, so obviously the current will flow, and here we will see there is no flow of this current here. So directly it will charge, the capacitor will get charged continuously. But when if the switch means the transistor is getting closed, switch is closed, then whatever the charge has been done, it should be going to this paths, they will follow, because this is in the parallel section, so it is going to discharge this.